Welcome back, everyone. Today on The Explainer, we're jumping right into a real game changer in the programming world, Python functions. Honestly, whether you're just starting out or you're trying to solidify those core foundations, understanding how to build your own custom tools, that's the secret sauce. It's exactly what takes you from just typing out simple little scripts to engineering real, robust applications. So let's get into it. We're going to start with a super relatable problem. Picture this. You're working on a script, maybe a basic automation task, right? Or a simple game. And you figure out the logic to, I don't know, calculate a score or format a user's name. And it works perfectly. You're feeling good. But then, 10 lines down, you realize you need to do the exact same thing. So what do? Well, you copy the code and you paste it. And then you do it again and again. And man, very quickly, your script turns into this messy, unreadable, and frustratingly fragile wall of text. Plus, if you find a bug in that logic later, oh boy, you have to hunt down and fix every single pasted copy. I mean, there has to be a better way, right? Well, there is. And here is our roadmap for figuring it out today. We'll cover what Python functions actually are, defining your very first function, passing data with arguments, getting data back using return, and finally, understanding variable scope. All right, section 1, what are Python functions? So think about the built-in functions you probably already use all the time, like print or len. Those are off-the-shelf tools that Python just gives you out of the box. But when you need specialized custom tools, well, our sources define a Python function as a handy way to create blocks of code that you can reuse. Think of it as a named container for a very specific set of instructions. You write the complex logic just once, and then you can reuse it infinitely with just a single word anywhere in your program. It's brilliant. And building these functions gives you 3 massive benefits. Any serious programmer will tell you this. First up, reusability. This saves you so much time and literally eliminates that copy-paste nightmare we were just talking about. Second is organization. Your code goes from being one massive, rambling script into beautifully structured, logical, bite-sized chunks. And the third one is abstraction. Now, abstraction just means hiding the complex stuff. When you use a custom function called, say, calculate_taxes, you don't need to look at the nasty map inside it every single time you use it. You just trust that the tool does its job. Let's move to section 2, defining your first function. Okay, time for the practical phase. Let's construct one of these reusable tools from scratch. There are 4 really simple syntax steps here. First, use the keyword def. That is just Python's way of saying, hey, I'm defining a new tool here. Second, give your function a descriptive name. Make it obvious what it does. Third, add a pair of parentheses and follow that right up with a colon. That colon is absolutely crucial. It signals to Python that a new block of code is about to start. And step 4, you have to indent the code block underneath. You know, in some other languages you might use curly braces, but Python relies strictly on indentation, usually 4 spaces, to know exactly which lines of code actually belong inside your function. So, putting that all together, if we wanted to make a tool that simply says hello, we'd type def, then the name, greet, add our parentheses and a colon, and then on the indented line right below, we'd write print hello. That single indented line, that is the entire body of our function. Pretty simple. Now, here is a super common beginner mistake. Running this code and expecting it to instantly print hello to the screen. If you run just those defining lines, absolutely nothing happens visibly. Why is that? Well, the key thing to grasp here is the difference between defining and calling. What we just did was define the function. We drew up the blueprint, we built the tool, and just set it on the workbench. But, just building a hammer doesn't automatically drive a nail into the wall. Just writing the def block doesn't execute the code. To actually make it do the thing, you have to actively call or invoke the function. And to use that blueprint, you just type the function's name followed by parentheses. By typing greet and empty parentheses directly into your script, you're commanding Python, hey, go find that block of code I defined earlier and run every instruction inside it right now. Only when that specific line runs will you finally see hello pop up on your screen. All right, on to section 3, passing data with arguments. So our basic greet function is cool, but it's a bit rigid. It only ever says hello exactly the same way. To spice it up and customize it, we use parameters. Think of a parameter as like an empty slot just waiting to be filled. You literally just add a variable name inside the parentheses when you create the function. It acts as a placeholder for incoming data. If we add a parameter called name, we can then seamlessly inject whatever that name ends up being directly into our greeting logic. Then, when you actually want to use the function, you pass in the data. Think of it kind of like ordering from a restaurant menu. The function itself is the dish, and the data you put inside the parentheses is your custom instruction, like asking for no onions. So, if you type the function name and put your name, let's say Bartosz, inside the parentheses, Python grabs that string, drops it into our placeholder, and dynamically prints out a totally customized "Hello, Bartosz." And Python gives us incredible flexibility here, which makes these custom tools so adaptable. You can use positional arguments, where the order you pass the data exactly matches the order of the parameters you set up, or you can use keyword arguments. This is where you explicitly name the data being passed in, so the order literally doesn't matter at all. Actually, you can even set default arguments in your definition. This provides a built-in fallback value, so the function still works perfectly fine even if the user totally forgets to pass any data. It's so robust. Moving right along, Section 4, Getting Data Back Using Return. Up until now, our little conceptual functions have just been printing text. But in real-world programming, you rarely just print things. Usually, you want your function to crunch some numbers, process some data, and actually calculate a result to hand back to you. The official Python documentation puts it perfectly. The return statement returns with a value from a function. The word return is the specific mechanism that securely sends data back from the isolated little world of the function, right out into the main flow of your program. And the documentation also notes a really critical detail here. If you don't explicitly include a return statement, Python silently returns a special built-in value called none the moment it hits the end of the indented block. Let's look at an example. Imagine a simple math function that adds two numbers. Let's call them x and y. Instead of using print, you use the return keyword, followed by the actual math expression. It takes the two inputs, calculates the sum, and instantly hands that result back out. Now, here is a golden rule. The moment a function hits a return statement, it exits completely. Done. Finished. Any code you write inside the function after that return statement, it's never going to run. So because a function hands a value back, you can capture it. When you run your math function with two numbers, you can just assign that entire call to a brand new variable to securely store the result. Just like that, you have the calculated number safely held in your script. You can print it, plug it into another equation, save it to a database later, whatever you need. Finally, Section 5, Understanding Variable Scope. We have reached the final and honestly the most frequently confusing concept for new developers. Scope dictates where your variables actually live and breathe, and where they are completely invisible. Think of your main Python script like a public town square. Variables created out there are in the global scope. Everyone, including any functions you write, can see them. But a function is like a private, closed-door workshop. Variables created inside that indented function block are in the local scope. They only exist while the function is actively running, and the town square outside cannot see them at all. The ultimate gotcha of variable scope is exactly this. If you create a temporary variable inside your function, the outside global script simply has no idea it exists. The workshop doors are closed. If you try to access it from the outside, it will literally crash your program. If you want the global script to know about that internal calculation, you absolutely must use the return statement we just talked about to explicitly pass it out the door. And that brings us to the end of our roadmap today. We've explored how to define functions, how to pass data in, return data out, and manage where all our variables live. You now have the knowledge to turn a messy, repetitive script into a clean, highly organized, and infinitely reusable Python program. So, here is my challenge to you. Open up your code editor right now. Take a script you've already written, spot the repetition, and replace it by forging your very own custom functions. What will you create with your new tools? Thanks for hanging out with me on this explainer, and happy coding.